Hi guys, happy to see you all. Uh, Actually, yesterday I posted a PowerPoint presentation to show the electric field due to an electric dipole in its axial line and also in its equatorial line. Actually, both are each are 5 mark questions. Both are very important one, especially in the first lesson. Now, I am going to explain through this video. I hope it will be helpful to you. First of all, we have this one, like this is what the question I would like to explain to you. This is the electric field due to a dipole in its axial line and also its equatorial line. Okay, now you can see the diagram. The first, in the axial line is nothing but line which is present, like you can see. So here, so this is the axial line. This is to electric dipole. Yesterday I told you in that video, in that thing, how the two equal and opposite charges will be separated by a small distance. It is constitute an electric dipole. So this is electric dipole. In this electric dipole, from here we are going to measure the electric field at the point C. So where the C will be located from the center O, the distance R. And we know that from O to B is A and O to A is A. So each one, minus Q and also the plus Q, will contribute the electric field at the point C. So now from this equation, E plus is equal to 1 by 4 pi epsilon naught Q by R minus A the whole square, and E minus 1 by 4 pi epsilon naught Q by R plus A the whole square minus, and both are representing on the same vector, that is P vector. P vector denotes the x direction, that is you can see. Now so through this the resultant field will be the summation of these two. So when I make the addition, Q by 4 pi epsilon naught will be the constant term, common term, so I can take it out. So the remaining term will be here. So this is what I show you in the PowerPoint presentation. Okay, so in the first one I show how the electric field due to an electric dipole in its axial line. Okay, and the resultant will be here. And one of the important thing here is when the the electric field will be considered very far away from the point center. So it was located, the point C is very far away from that. So the R is very greater than A. So here we can reduce that equation into E total will be equal to 1 by 4 pi epsilon 2 P by R cube. This is the first one. And one more thing we can find, E is directly proportional to 1 by R cube. Please note it down. E is directly proportional to 1 by R cube. And now the next one we are going to see is the electric field due to an electric dipole in its equatorial line. So this is a little broad one. Here we have to carefully listen. See, in the axial line there won't be any problem. We are not going to discuss about the angle. But in the equatorial line is nothing but, here you can see, look at that diagram. So the point, or that is the point where it will be perpendicular to the bisector, that is C. Okay, so in this C you can find, I will show you here. So this is a point C and this is a point O. So from here you have to measure the thing, right? Now the next one we are going to see is, even here it has to charges plus q and minus q. So both will be representing the electric field at the point C. So it has the summation EP will be equal to EA plus EB. So now I am considering the point C. Here in the notation I have given P. Okay, you can just change it into EC. Right. Now the direction of E plus is along BC and direction of E minus is along CA. See, E plus will be moving out from the charge, E minus will be moving towards the charge. So for EC, EC due to the plus positive, it will be moving towards this direction, and for minus q, this will be moving towards this direction. So this is what mentioning here, and I will show you through this one. Now the resultant field will be the summation of two electric field. So I will measuring, and at the point C it has two components. Look here, the two component will be, so here at the point B plus q is there, at the point minus q, A minus q is there. So the point C we are going to measure the electric field. So here at the point C, due to plus q, I have the two components, that is E plus sin theta, that is a perpendicular component, and E plus cos theta, that is a horizontal component. And in the point C, I have due to minus q, that is E minus sin theta, that is a perpendicular component, and here E minus cos theta, that is a horizontal component. Obviously E plus sin theta and E minus sin theta will be getting cancelled. So only the cos theta component will be contributed. Okay, right. Now look at this one. Here we have, so the sin theta will be getting cancelled, cos theta component will be contributed, and there are two cos theta, and moreover the both are representing the same value, that is E plus will be given the same value and E minus will also given the same value, that is R plus R square plus A square. So when I have taken 2q, that is 2 times q cos theta, that is q by 4 pi epsilon naught is a common term, and R square plus x square, A square, and cos theta will be taken from the diagram, that is A by R plus A square whole to the power 1 by 2. Here cos theta will be equal to A by R plus A square whole to the power 1 by 2 by using Pythagoras theorem. So now I will get the final value will be P by 4 pi epsilon naught R square A square R square plus A square whole to the power 3 by 2. Okay, and since P is equal to 2QAP, and X again I am using the same assumption, that is for the very large distance R is very greater than A, so I can reduce the term into E total will be P by 4 pi epsilon naught R cube. And the difference between the axial line and the equatorial line is, for the axial line the value will be 2p by 4 pi epsilon naught R cube, but for the equatorial line it is p by 4 pi epsilon naught R cube. That's it. Thank you for watching.